Okay, so we're diving into something pretty interesting today. Domain-driven design, or DDD for short. You sent over some excerpts from Eric Evans's book, Domain-Driven Design, Tackling Complexity in the Heart of Software.
Yeah.
And I have to say, this is a classic for a reason. It's all
Oh,
about,
yeah.
you know, building software that it isn't just technically sound,
Yeah.
but really reflects like the core of what it's meant to
It
do,
really does flip the script on how we think about software.
right?
Yeah.
I think that's where a lot of software projects go wrong. They get so caught up in the how that they kind of lose sight of the what.
Mm,
And DDD, I think, really helps us avoid that trap. So that's what we're going to unpack today.
sounds good.
We'll explore those core principles, the why behind it all, and hopefully uncover some of those aha moments that make DDD so powerful.
And speaking of aha moments, Evans shares a pretty fascinating example in the book, the share pie breakthrough, where a seemingly decent model gets completely reframed. We'll get into the nitty-gritty of that one a little bit later.
Okay, I'm already intrigued. But let's not get ahead of ourselves. First,
Yeah.
what exactly is domain-driven design? It's more than just writing code.
Right. Absolutely. It all starts with understanding the essence of the business or activity that the software is supporting. We call this the domain. And DDD is about building a model, a structured representation of that domain. You can kind of think of it as the blueprint for your software,
Okay.
but it's not just a technical diagram.
So it's more about understanding the problem space itself.
Exactly. The domain model captures the key concepts, the relationships and rules that govern the domain. It helps us identify what's important, what needs to be represented in the software, and how all those elements interact. And this is where collaboration between developers and domain experts becomes absolutely crucial. You need that back and forth, that shared understanding to create a model that's both insightful and accurate.
And Evans actually highlights this really well in the book
Mhm.
with the story of designing software for printed circuit boards. Now, he had no prior knowledge of electronics, but he did have access to PCB designers, the domain experts in this case,
Right.
and he had to dive deep, asking tons of questions, clarifying all this terminology, and really getting into the nuances of PCB design.
Yeah.
You know, it was a real process of knowledge crunching, where the domain expert's knowledge was combined with Evans' software design expertise.
So they were building this shared understanding, not just of the domain itself, but how software could actually represent that domain. It really sounds like this collaboration is key to getting that model right.
It's absolutely essential. That model becomes a bridge
Yeah.
between the world of the domain and the world of software.
Yeah.
And this leads us to a concept called model-driven design. Now, in a traditional approach, you might create a model during the analysis phase, but then it kind of gets abandoned. As you start coding
Right.
in DDD, the model isn't just a planning tool. It's the driving force behind the code.
So the model's actively guiding the development process, not just sitting on a shelf somewhere gathering dust.
That's right.
This is a pretty big shift from how software is often built. It is. And to make this work effectively, DDD emphasizes a layered architecture for your software. Imagine it like a layer cake, with distinct layers each having its own responsibility. So you have the user interface at the top, the application logic in the middle, and then the domain layer at the bottom, where your precious domain model resides.
I'm sensing a theme here, separation of concerns. Each layer has its own job, and the domain layer is where all the magic of the domain model happens.
You got it. That isolation allows the domain model to really shine without being tangled up with the technical details of the user interface or the complexities of the application logic. And this leads us to a cautionary tale that Evans calls the smart UI anti-pattern. It's about what happens when you try to cram too much logic into the user interface. It might seem convenient at first, but it can quickly turn into a nightmare.
So the smart UI anti-pattern
Yeah.
is like trying to bake a cake, but mixing all the ingredients together in one big bowl instead of layering them carefully.
Yeah.
It might look like a cake at first, but the texture and taste will be all wrong.
Exactly. You end up with a tangled mess. That's difficult to understand, maintain, and extend. And that's the opposite of what we're trying to achieve with DDD. We want our code to be clear, expressive, and maintainable.
Okay, so how do we actually build this domain model? What are the building blocks? What are the ingredients that we need to create this masterpiece?
Well, we've got some great ingredients to work with. First, we have entities, which are objects with a distinct identity, like a customer or a product in your system.
Okay, so entities are the things in our domain, the nouns of our software world.
Right.
They sound a lot like database records, but they're more than just data containers.
Right. You're right. They encapsulate both data and behavior. And then we have value objects, which represent characteristics or attributes. Things like an address, or money amount.
So if entities are the nouns, value objects are more like the adjectives, describing those entities.
That's a helpful way to think about it. They add richness and detail to our model. Then we have services, which model actions or operations, the verbs of our domain. These stand alone, without encapsulating state, like a funds transfer service.
Got it. Services represent those actions that happen within our domain, those processes and workflows that make things happen.
Exactly. And finally, we have modules, which help organize all these concepts into cohesive units. Think of them as the chapters in your domain model, grouping related concepts together, like a shipping module or an accounting module.
So modules provide structure and organization, helping us manage that complexity of the domain.
Exactly. Each of these building blocks plays a crucial role in crafting a model that accurately reflects the richness and complexity of the domain. But the real magic happens when we start refining this model, challenging our assumptions, and searching for those deeper insights that can lead to breakthroughs in our understanding.
You're talking about the SharePie breakthrough.
Right.
The story where they had a seemingly good model, but then they discovered a deeper, more elegant way to represent the domain.
Exactly.
I'm dying to know what triggered that aha moment.
We'll hold on to that thought.
Yeah.
Because that's where we'll pick up in the next part of our deep dive. We'll unpack the SharePie story and explore how a focus on language can lead to those game-changing insights.
Okay, I'm hooked. Can't wait to hear how that story unfolds. But before we move on, is there anything that particularly stands out to you so far? Anything that resonates with your own experience? Or sparks a question?
Well, I think one thing that always strikes me about DDD is how it shifts our focus from just writing code to really understanding the problem we're trying to solve. It's about,
Yeah.
building that deep connection with the domain and using that understanding to guide our design choices. And I think that's a really powerful idea.
Yeah, absolutely. I think that's a really good point. And it's something that we often overlook in the rush to get things done. But taking the time to really understand the domain can pay off in huge dividends down the road. It can lead to more elegant, more maintainable, and ultimately more successful software systems.
Exactly.
So to our listeners out there, I encourage you to really embrace that mindset of deep understanding as you embark on your own domain-driven design journeys. It's a journey worth taking.
I completely agree.
All right, so we're going to take a quick break, and when we come back, we'll dive into that fascinating SharePie story and explore how a simple shift in language can unlock profound insights into the domain. Stay tuned.
All right, so where we left off, we were about to delve into that SharePie breakthrough. This was in the financial world. They were building a system for managing loan participations. Pretty complex domain, investment banks, lenders, borrowers, lots of moving parts.
Yeah.
They had created like a functional model, but something just wasn't quite right.
So the software wasn't like crashing or anything, but it just didn't feel like it truly captured the essence of those loan participations.
Exactly. The code worked, but it lacked, a certain elegance or something. Evans describes it as this feeling of the model not fully aligning with how the domain experts actually thought about the problem.
Yeah, I can relate to that. Sometimes you just have this like nagging sense that there's got to be a better way, more insightful way to represent things.
So what was the turning point in the SharePie story? What made them realize that there was a deeper model waiting to be discovered?
It was all about the language. The domain experts, the financial folks kept talking about like portions of the loan and slices of the pie being allocated to different lenders. And this language of SharePie wasn't reflected in their model at all.
Interesting. So their model was focused on like individual loan participations, but the domain experts were thinking about the whole loan and how it was divided up.
Precisely. They were missing a key concept. That reflected the mental model of the domain experts.
The existing model, with its focus on individual participations, just felt clunky and didn't really capture this whole SharePie concept.
That must have been a pretty big realization for them. They could have just kept going with their existing model.
Yeah.
But they chose to refactor. So what were the benefits of making that change?
Well, by shifting their focus to this SharePie as like a central entity, they could encapsulate a lot of the complexity and make the design much more expressive. It became easier to like calculate payments, handle ownership changes, and even just communicate with those financial experts using their own language.
So the model became more aligned with the business reality, the way these experts actually talked about and worked with these loans. And that's such a crucial aspect of DDD, isn't it? It's not just about finding like a technically clever solution. It's about creating a model that truly reflects the domain.
It really is. It's a powerful example of how even a subtle mismatch in language can point to like a deeper, more insightful model. This new model didn't just make the code cleaner, it actually improved communication and collaboration
Yeah.
between the developers and the domain experts. They were now speaking a common language, which, as you know, is a cornerstone of DDD.
Yeah, this idea of a ubiquitous language
Yeah.
is so important. It's not about developers having to learn all the financial jargon. It's about creating a shared vocabulary that reflects the model and how everyone thinks about the problem.
Absolutely.
So we've seen how powerful it can be to make those implicit concepts explicit. But how do we actually do that?
Well, Evans has a whole chapter on this, aptly titled Making Implicit Concepts Explicit. It's a process of paying close attention to the language used by domain experts, looking for any inconsistencies, challenging assumptions, and really experimenting with different ways to represent these concepts in the model.
So it's more than just passively listening. It's about active engagement,
Right.
asking probing questions, and really digging into those nuances.
Yeah, you got it. It's a constant back and forth, refining the language and refining the model. And sometimes the most insightful discoveries can come from unexpected places, even looking at completely different domains.
That's what's so cool about this, right?
Mhm.
It's about connecting the dots,
Yeah.
seeing patterns. That might not be obvious at first glance. Do you have any examples of this cross-domain inspiration in action?
Well, in the book, there's a great example of how the team drew inspiration from accounting principles to model financial transactions within their loan system.
Okay.
They were struggling with the complexity of calculating interest and handling all these different financial scenarios. Their existing model was becoming like a tangled mess, and they needed a fresh perspective.
It sounds like they needed a way to simplify things, to find a more elegant way to represent these financial transactions. So what do?
They realized that the core concepts of accounting, like debits, credits,
Yeah.
and ledgers, could actually be applied to their own domain.
That's brilliant. So they borrowed ideas from a completely different domain and applied them to their specific problem.
Exactly. And it worked beautifully. By using these familiar accounting concepts, they created a much more robust and elegant model for handling financial transactions. It simplified the code, made it easier to understand, and ultimately led to a more maintainable system.
That's such a great example of how stepping outside of our immediate domain can lead to those aha moments. Okay, so we've seen how focusing on language, actively engaging with domain experts, and even drawing inspiration from other domains can lead to deeper insights and breakthroughs. But we need to translate those insights into code, right?
Yeah.
We need to talk about how we actually implement these elegant models in the real world of software.
You're exactly right. In the next part of our deep dive, we'll explore the principles of what's called supple design and see how those translate into code. That embodies the elegance of the domain model.
Okay, I'm ready to get into the code and see how all of this comes together in practice.
Yeah.
Okay, so we've explored the domain, built this beautiful model, and now it's time to bring it all to life in the code itself.
Yeah.
This is where things can get messy if we're not careful.
Yeah, that's where the principles of supple design come in. It's all about ensuring that our code reflects the elegance and expressiveness of our domain model.
So it's not just about making the code work,
Yeah.
but making it work well, making it something that,
Yeah,
other developers, maybe even our future selves, will thank us for.
exactly. We want code that's easy to understand, easy to modify, easy to extend, code that's like a pleasure to work with, not a tangled mess that makes you want to pull your hair out.
Yeah, no one likes dealing with tangled code. So how do we achieve this supple design? What are the secrets?
One of the key principles is creating what are called intention-revealing interfaces. Think about, the way you interact with a well-designed piece of software. The buttons, the menus, the commands, they're all clear and intuitive. It's the same idea with our code.
So we want our code to be self-explanatory, like a well-labeled map that guides you through the system.
That's a great analogy. Every class, every method, every function should have a clear purpose that's evident in its name and its structure. So instead of having like a generic method called calculate loan payment, you might have something like allocate share of principal payment, which immediately tells you what that piece of code is doing.
Yeah, I can see how that would make a huge difference, especially when you're working with a complex domain. You don't want to have to dig through lines of code
Yeah.
to try to figure out what's going on.
Exactly. Intention-revealing interfaces just make the code easier to read, understand, and maintain. Another important principle is separating side effects from pure functions.
Okay, break that down for me. What's the difference between a side effect and a pure function?
So imagine a pure function, like a simple math equation. You put in the same inputs, you always get the same output, no matter what. There's no hidden magic or surprises.
So like a function that adds two numbers together
Hmm.
would be a pure function.
Exactly. It takes two numbers, adds them, returns the result. No changes to the outside world, no side effects. Now, a side effect is anything that modifies the state of the system outside of that function's scope. Things like updating a database, sending an email, or even changing the value of a global variable.
Ah, I see. So side effects can make the code harder to predict because they're kind of doing things behind the scenes.
Right, they can introduce unintended consequences and make the code more difficult to test and debug.
So by keeping those pure functions separate, we're creating more predictable and reliable code.
Exactly. It makes the code easier to reason about, refactor, and test. And this brings us to another important aspect of supple design, leveraging design patterns.
Ah, yes, design patterns. These are like pre-baked solutions
Yeah.
to common software design problems, right?
They are. But in DDD, we apply those patterns, not just at the code level, but also at the domain level. We're looking for solutions. That makes sense both technically and in the context of our domain.
So it's about finding the right tool for the job, one that fits both the technical constraints and the nuances of the problem space. Can you give me an example of how a design pattern might be used in DDD?
Sure. Evans talks about using the strategy pattern to model different routing policies for shipping cargo. So instead of having a bunch of if-else statements scattered throughout the code to handle different routing scenarios, you could encapsulate each routing option as a separate strategy.
So you'd have like a fastest route strategy, a cheapest route strategy, and so on, each implemented as a separate object.
Exactly. And you could easily swap or combine these strategies. Based on the specific needs of the shipment, it makes the code more flexible, more maintainable, and more aligned with how the domain experts think about routing options.
I like it. It feels more organized, more intentional. Are there any other design patterns that lend themselves well to DDD?
Absolutely. Another great example is the composite pattern. It lets you treat individual objects and compositions of objects uniformly. Evans uses this to model different levels of a shipping route, from individual legs to entire itineraries.
So you could have a single object representing a leg of a journey and another object representing the entire journey, and both would be treated as part of the same hierarchy.
That's the beauty of the composite pattern. It allows you to create these recursive structures that mirror the way things are organized in the real world, and this can make the code more elegant and easier to work with.
It's fascinating how these patterns can help us bring order and structure to what could otherwise be a chaotic tangle of code.
Absolutely. It's about finding those elegant solutions that bridge the gap between the domain and the code, creating a system that's both powerful and a joy to work with.
So I think we've covered a lot of ground today. From the core principles of DDD to the nitty-gritty of supple design, we've explored the importance of language, collaboration, and strategic design choices.
And most importantly, we've seen how all of these elements work together to create software that truly reflects the richness and complexity of the problem space, while empowering developers to build solutions that are both elegant and maintainable.
Yeah, it's been a real eye-opener for me. And I hope for our listeners as well. Domain-driven design isn't just about following a set of rules. It's about approaching software development with a mindset of deep understanding, collaboration, and continuous refinement.
It is.
So to our listeners out there, keep learning, keep refining, and keep building those beautiful systems. Until next time.